So before starting, so I will somebody asked last class that some things like some overview what we are doing. So last night was very difficult. Last class was these are likely that more or less these are the topics that I am going to discuss, and these components, some of the components may take like a more time than other components. Right, so air pollutions, we have started the criteria of pollutions that we are going to discuss today, which many or may not be able to complete today. Then after that is mobile stationary sources of different criteria of pollutants and their control, different techniques that we will be discussing. Then meteorological effects on air pollution, means how is the air stability, that pollution discussion, etc. Related to that, this Gaussian plume model that we will be discussing, and at the end that indoor air quality, where we will be implementing that simple box model that I think already mass energy balance that has been discussed, right? At that time you already know about that. Then we will be going to this water pollution. Again, that what are the different type of these pollutants are there in case of water, and then we will go to directly this BOD, right? So biochemical oxygen demand. And the water quality in lakes and reservoirs. Before that, this when BOD will be discussing is water quality, because ultimately right. So ultimately this generally BOD etc. it goes to the river. So in that, related to that we will be discussing a river model, that discussion of the BOD. This okay, and this plug flow, that reactor, that already I think that also you are familiar with. Okay, and then groundwater will take a little more time. Okay, and after that we will be discussing that what is the water quality control. Not all, but some relevant part in case of like our daily use water, means that your municipality water we use. Right? These last four, I will be trying to discuss thermal pollution, as I said, I will get some idea. So we won't be discussing that much, because this too will take a lot of time. But we can just like one or two classes, one class of course, 2 classes that we will try to sum up it. Okay. So these are this is your overview of this. These 2 books that I am going to follow. Right. Gilbert Masters, I think your mass energy balance, that time you are already familiar. Right. I have introduced this book. It is Rao Environmental Pollution Control and Engineering. Mostly I will be discussing when these air pollutions, different techniques, mitigation techniques that I will be discussing, that time these books I will take here. Okay, so these are the 2 books. Chapman is ecological. That is over. So that part is your ecological, right? Ecology and environment. For environment pollutions, now this Chapman, whatever the environment pollution part is there, in a lot of details are given here. That is just in terms of ecology. Right, so these are, we have already again introducing, because right now today's class you can consider that the start of this our air pollution. Right, so you know that this naturally that air pollution means whatever the pollutants you consider that, so their amounts are in a steady state, it is there. However, our anthropogenic, like the human behavior, that actually try to do the imbalance, right? And therefore, when there is an adverse health effects are there, so therefore we call it there is air pollution there. So where these things actually comes into the picture, then naturally the 2 things comes into your mind. One is that what are the things that is actually causing that health effects, affecting our health. So that is those are the what are the pollutants of that, right? Yeah, and where imbalance is taking place. and what are the sources. Well, what their activities are so much is there, but you have to identify which activities are actually coming to the picture. And therefore, all these things actually again comes into the picture like a from Clean Air Act. And Clean Air Act, what does it do? It tells us that your emission norms and your air quality standard. Ultimately, these are the things that it takes care of. Right, so so first thing is that your classification of the polluters. So classification, the primary classification is that you can, broad classification is that primary pollutants and the secondary pollutants. Primary pollutants are these emitted directly into the atmosphere. Secondary pollutants from the primary pollutants in different way, different physical and chemical processes is actually again created in the atmosphere. Right, and these are the these creation processes are there, which is combustion, evaporation, and grinding, ablation. And this primary pollutant, like you can see that one example is given that for this methane emission, methane when it is a burn, then this CO2 is emitted there, and it will be in conflict burn, then it actually creates this carbon dioxide. And similarly, that when during this combustion here, because of this heat, this thermal NOx means like in nitric oxide, NO2, these are actually produced there, and nitric oxide actually mostly. It also has like a different health effects. Okay. Secondary pollutants, this example is these are the VOCs are there from different solvent and the fuels. Directly from the evaporation, there are like these different hydrocarbons actually that comes out. So these actually contains the, composed of this VOC, and VOC in terms of NOx, when it touches with the NOx and in presence of sunlight, this actually can create a photochemical smoke, including the ozone, ground level ozone, right? So these are all the secondary pollutants. So these are the things like we are going to discuss today. Right, so from the Clean Air Act, as I said, that please give it a read. That Deepak must have give it a read. Now, what is the history of it to understand, right? So when the Clean Air Act, etc., has come. But anyway, that these are the most important criteria pollutants, the most important in terms of that how it affecting our health, and these are the identified criteria pollutants. So carbon monoxide, sulfur dioxide, nitrogen dioxide, ground level ozone, and this particulate matter, and of course lead. Okay, and from where it is emitted, again the broad category is that your mobile sources, means that your automobile, right, higher vehicles, rails, aircraft, farm vehicles, seats, etc. Even your lawn mower also, that also contains the engine, and the stationary sources, power plants, industrial energy system, etc. Okay, so means that you see that NOx is one of these things which is the curbing is a very difficult thing, and you can see that both is 50%, they are actually contributing from the mobile as well as the stationary. Right, so now these things already I think has been discussed earlier, but just let us just recap once again. So these concentrations of the pollutants. So concentration of the pollutants is generally like a ppm or microgram per meter cube. Sometimes if it is high, then milligram per meter cube, right? So these are the three things are introduced, and then you can see that means that the last one, NP by VA plus dB, this means that microgram per meter cube, and simply that this one, there is a ppm level, this is a volume concentration is there, and this volume concentration and ppm means that you are just scaling it to the 10 to the power 6, right? So means that whatever these units are there, say liter, milliliter, whatever, so amount of air like a 10 to the power 6, and you represent that also in that. Okay, so because the concentrations are very small, if it is a really high, then it will be really disaster. So that's why ppm is the one way to represent it. Right, and this is the way of converting from, it may be required sometimes that the ppm it is given and you want to converting in this your concentration in that this mass volume ratio. So means that microgram per meter cube, and this is one of the examples which is given in that your book, and you understand that volume, gaseous volume is there, so therefore your this standard standard temperature pressure is actually required there, or whatever the temperature is required there. Yes. So therefore that you can see that it's 24.465. This actually comes that what was the air is contains that at 1 atmosphere 25 degrees centigrade, that 24.465 liter it contains, and from there taking this this molecular weight you can convert it. So it was a 0.25 ppm, which is I will discuss it. This is the ambient air quality standard, 0.25 ppm for NO2, not emission standard. And when you want to convert it, you can see that it is giving you 470 microgram per meter. Okay, so please be familiar with these things, right? That how to convert it. So this is your air quality standard, which changes time to time, right? It is evaluated actually, monitored that. And this national air ambient air quality standard, it is for that, and you can see that two standards are compared there. I took it from the Gilbert Master's book, and this is the national is that American national, right? So US there. And they state to state actually that things also change there. So one is the California state, and another is the national state figure. And you can see that what is given, the carbon monoxide. This is the first. So carbon monoxide means that if it is a so means that there might be like the sources are there where there is continuous, there is actually emitting like that. So in that case means that your safe standard is 9 ppm, right? That is what it is, 9 ppm. Whereas it may happen like an averaging time, so it is like a 1 hour source, which is not like a more than say 30 minutes or something like this. So in that case, that it may like a 1 hour, that's safety standard, and they given as a like a 35, right? Because 9 and 35 you can see. So exposure level actually changes that. You are like a more and more you are getting exposed to a particular pollutant, and you are at a more risk, right? So that is the thing about indoor air quality, right? Indoor air quality, when we discuss that, indoor air quality, when the air pollutants, you will be doing that it is a rare, because indoor controlled air is there, right? But therefore you have your all this control is there, but the thing that the pollutant concentration is like a very low. However, it may happen that, for example, this asbestos, etc., these materials, these things are actually used there. Some kind of paint can be used there. From the paint, this evaporation that is coming there, VOCs are coming there. But the point is that when you are spending so much time, work hours, sometimes it is so high there. So the exposure levels actually changes, right? So that actually creates a problem. Okay, so the other you can see that this lead, where is ppm, where the lead is actually there 1.5 microgram per meter cube, and this point right here, and you can see the particulate matter, and this is given as 150 microgram, right? This one I have taken directly from our, you can just give a search, our air, this air quality standard, and CPCB site, and everywhere it is given there. Right, and here you can see that this one is an animal, and even again for that purpose, it is given one the first number in a animal and one is 24, and here the units are given except like this carbon monoxide, which is given in a milligram per meter cube. Others are all have actually micro, and one is this last one is a nanogram, other is microgram and nanogram and milligram is given.
So, yeah, so this ppm increases as the distribution of gas in the environment. So this ppm value decreases as we increase exposure time. This is due to the distribution of gas in the environment.
No, ppm, it doesn't matter. ppm or what this is.
Lines of the carbon monoxide and AQs. So that value decreases due to the increase in exposure time, like because of the distribution of the
No, value doesn't decrease. No value doesn't exist. This is the standard value. It is said that if you were in this room, you are staying it for 8 hours. The average it should be from 8 hours should be 9 ppm. Understand that? Okay, 9 ppm. However, say you are staying it for example, like a 1 hour or something like that. I say it is emitting, but you are staying is a 1 hour, is a 30 minutes less than 1 hour. That time it may happen like a 35 pm. Okay. So your exposure time is like a increasing. Now, I mean that is quantified there. You have to see that how much you are taking. Carbon monoxide you are taking. That is a different thing. But here in the air, the standard should be 9 ppm. Got it? Like which is a on average state. Of course, it will be changing. It can change it. But if there is like a steady state, something, some source is there at steady state, it is emitting. Then on average, it will be same, right? A steady state value. Okay. Little bit changes are there. Okay. So in our case, this National Air Quality Index, when AQ of that we you are familiar, right? Every day what is given there. So these are the things that is considered for our India standard. Okay. And this AQI category, see this range, right? So again, other things which is you can like a PM10, for example, your microgram per meter cube. Like first column say. So 0 to 50, like you see the index you see, right? So it doesn't exactly, for example, if it is a 101 to 250, then the number which is given 101 to 200, right? 200, right? So here, I mean, where like every this AQI that is represented, you know how you do this calculation. Okay. So yeah, I thought maybe it is not given in the book, but it is of course interesting to know for our. So see here. So there is this sub-index that is actually given there, and this from sub-index that we have to calculate for every pollutant. Okay, and this sub-index when you calculate that, which is giving the maximum, that is the AQI you have to represent. Okay. So for example, say sub-index for a pollutant, a formula for calculating sub-index is false. So upper limit of the previous AQI category to which the pollutant current reading would have fallen, plus this what is the current reading minus upper limit, and filter internal of the AQI category for the current level of the reading. Okay. I just have the example. So PM 2.5. So you are measuring it is a 150, right? 150 microgram per meter, right? So then what should be the sub-index for PM 2.5? So what we have to see that upper limit of the previous AQI category to which the polluter's current reading would have fallen. So where is it? 150. This 150 comes sorry, PM 2.5, right? 2.5 I said, right? Yeah. Yeah. So the last one, right? So 150 is very poor. Shall we see it? Actually, I don't know. The last one is not visible. It is actually coming in very, very poor. So one here, 121, let me write it here. So there is a very poor is coming like this. Very poor. I think that is what you are not able to see, right? Very poor. And given 301, right? And PM for PM 2.5, this is 281 to, sorry, 121 to 250. Okay, so means that 150 comes into in that way 121 to 250, right? Okay, 250, right? So 150. So the previous category, right? What was that? What was the upper limit of that category? Was it is a Okay. Right, it is a 300. Got it? This is 300. Okay, 300. And then after that, you have to see what is the, you see here, current reading minus upper limit of the previous reading category of the pollutant, which is like a 150 minus 120, like 150 is given, and 121 is like a 120, right? 120, 150 minus, that is the weight. And then again, we got interval of the equal categories for the current level of the reading, which is 301 minus 400, 100, and after that, by 130 is that what is the weight or interval of the current reading category of the pollutant. Means that 250 minus 150, right? Okay, so when you calculate it, it comes as a 3 to 3. Okay, so this is what actually, this is what calculated. This is formula, I think you can just follow it, just a simple formula. This is what calculated for every criteria pollutants which are given. You calculate for every pollutant, and after that which one comes in the highest. The O sub-index reflects overall equal. For instance, the sub-index of PM is 75, SO2 63, 38. Then it will be given AQI is 75. That is the most, and mostly it is coming from the particular point. That's why whenever the AQI is given, the first thing comes into mind. This is what PM 2.5. So this is that. Okay. This is it. Right, so now we are going to discuss about this criteria pollutants. So first thing is that let us go whatever is our Gilbert master is, and the 6 criteria pollutants will go by that. Go by that. So here the first one is the carbon monoxide. The carbon monoxide, so it is a deadly gas because it has a colorless, odorless, and tasteless. So you will be given like a award of its presence in the room. And when, how does it happen here? It happens because I created because of this incomplete combustion of the carbon gas fuel. Why does it happen there? Because of this inadequate oxygen supply, and it depends upon your high combustion temperature, right? I mean, it's not enough there. It depends upon a combustion engine, the gas residence time at high temperature, and combustion chamber turbulence. So, like, really like this combustion physics that is involved because of the CO emissions. Right? How? Because ultimately it leads to everything. It leads to the incomplete combustion. Okay, so that's why it mostly emanates from the transportation sector. So how do you curb it? You have to curb it by strict emission control norms. Discarding because when they are older, this engine becomes older, and therefore its performance actually degraded, and therefore CO emission actually increases. So that's why these norms are there. That when it is becomes older, and you just reject it. Like in our state also, the older polluting vehicle elevation drops CO emission. It has like a adverse human health effect because the CO that directly bond with your hemoglobin, right? And therefore it actually degrades your carrying capacity of the oxygen. Okay. So it is called this carboxy hemoglobin, a bond of CO to hemoglobin. And this CO exposure mostly like when there is transportations are there, so therefore this easy roadways, highway traffic, and then some little bit that comes out from your indoor pollution, which is a cigarette smoke. Right, so these are the next criteria pollutants, which is called these oxides of the nitrogen. Right, so there are like different oxides of the nitrogen are there. So the first like NO and NO2, which are like any to forgot some? Right. So the nitric oxide and the nitrous oxide, NO or NO2, these are the like to consider these react pollutants. So where does it come from? Two major these emitter is the thermal NOx and the fuel NOx from the combustion engine. And how does it come? Like one is like that. Thermal NOx means that when in the combustion engine, because the ambient air is there, and because it's a high temperature, this NOx is actually formed. Because it can the temperature can reach up to 1000. And the fuel NOx is there. In the fuel itself, the fuel component, there are nitrogenous compounds are there. When you are burning, then these NOx are actually getting produced. Right, so this nitric oxide, that emission is a 95%. It is colorless gas, no adverse health effects at the present concentration, which is found in the air. However, this NO that readily oxidized with the NO, right, which cause different diseases to human. Right. Other thing is for the NOx, what happens? This NOx reacts with the different this volatile organic compound, and in presence of sunlight, it forms a photochemical oxidant, which again causes different refrigerant. NO2 that can react with the atmospheric wave to form nitric acid, which corrodes metal surfaces, cause this acid rain and damage terrestrial plants and contributes significantly for the eutrophication. Right, and the problem is exactly difficult to carbon. Now, of course, we will be discussing later what are the different ways that can be implemented. This is the next one, which is the volatile organic compounds. So it comes from evaporation from the solvents and different fuels and other organics. And how does it happen? Unburned and partially burned hydrocarbons that are fossil fuel is not completely combustible, right? And these are the VOC are the principal reactant which causes the photochemical smoke, right? Which you can see in the early morning, right? The photochemical smoke. And there are like mostly it is the anthropogenic sources, transportation sector, industrial sources. And there are some natural like that. Some kind of this old trees are there which can emit this hydrocarbon. There are, I'm not giving this here example here. That is a complex compound. Right. So this is the photochemical smoke, which is an example of the secondary pollutant. Right? Secondary pollutant. And why? Because these VOCs which reacts with the NOx and sunlight and produce the photochemical smoke. So one of them, the secondary pollutant is the ground level ozone, which is directly created from the nitrogen and this nitrogen dioxide, NO2, right? And you will be seeing that there is like these hydrocarbons are also indirectly responsible for that. And there are like the direct other photochemical smoke which that these eye irritations, the early morning the eye irritations comes there. This I think one of them you are very much familiar. It is this peroxide, this nitrate fan. Right, so this is the photolysis cycle. Photolysis cycle for the ground level ozone formation. Right, so I am considering this thermal NOx. However, I mean, if it is the fuel NOx, with the fuel NOx also that the NO and NO2 both are actually produced. Right, so here the thermal NOx I am considering where the first step is that the nitric oxide which is forming, right? NO. Okay. So NO is forming, N2 plus O2 in the combustion reactor, which is at high temperature, NO is forming. From the NO, it is very reactive. The oxygen which is in the air, that quickly it forms the NO, right, with some rate constant. Then, when this sunlight, Like sunlight comes there and the intensity started increasing, means that daytime, right? Therefore, the photon which has a in a wavelength less than 390 nanometers. In presence of that, this NO2 it is broken into NO and O, and you understand that this oxygen atom it will be again very reactive, right? So the O and O2 recombine. So any recombination that will need another bond, free bond, right? So your means the recombinations of energy need to be released there. But the energy could be something that if they actually taken, when you can see that this terms you are familiar, right? Three body recombinations, right? Always in cycle, right? So therefore that they can again break through. So therefore that something is required for do that. So three body recombination, one is like that is wall sometimes this chamber wall, it is the reactor, chamber wall, etc. And near to the chamber wall it happens there. So here in the air what happens there? That maybe like the N2 and the O2 that acts as the third body which is given as a N. Right, and this ozone is formed. Right, so when the ozone is formed, one of the other reaction is that so ozone has a different health effects. Ozone is ground level, and of course it has a different is there when it is in the stratosphere. That is a different thing. Here in the ground level, when you are inhaling that, it has different other health effects which we have discussed, chest constriction, irritations, and this other products, etc. Right? So O3, that you see that O3 and it reacts with the NO and again it creates NO. So it is actually that's what is called the photolysis cycle. If the NO2 is there, again the NO2 is again forming this. Right? Right. So you can write this. Right. For example, the concentration of the O3, so you represent like this, right? The chemistry, etc. You know, right? With this third bracket, it can represent the concentration. And this one, if you want to monitor, say with the time. So what? How do you write it? First, the production term. And distribution, right? So what are the production steps here? Right, so this is how you write. Say there is a, see the production, direct production is where? This ozone formation, right? The ozone formation O plus O2, O3, right? So there will be some rate constant. Depends upon the rate constant will be depending upon the what is the temperature is there, what is the condition, external condition, right? But for a like a given atmospheric condition, it will be constant. Say it is a heat production, right? And what do you need? What should be the proportional to?
O3 and O3 and
It is a production, so it should be proportional to the what are the components it is forming of, right? Means that your O, and N is maybe N is also there. I have to see that. I think it should be also there because, but yeah, that it is actually as a catalytic. A catalysis it is there. I have to see that because you would have. So, okay, and that's similar to your discussions now, right? So, say, AB. And N, right? Okay. Fine. And you can write about your O. Similarly, you can write. How do you evaluate this one? That also you can write O and you can check. So there is a set of reactions you will be able to write. Most reactions are there, most set of this equation it will come. Right? And from here you can with some given scale values you will require, and you can find out the values, right? This what is the O3 with the time how it is different, that is how is it how it is changing with the time, right? This is the things you can find out. And if it is steady state, then it's okay. Steady state means everything is equal to 0, and you can find it out, right? Okay. So when you do this, right? So there you can see that NO2 tends to create O3, NO tends to destroy O3. So similarly, from here, this is one measurement which was done in Los Angeles, which is given in this book. So this is a measurement. What is given is it's a measurement data, and you can see that why it was measured from midnight to this. Okay, again midnight to midnight. The diurnal variations, the full daily variations it was there, and what it shows it. You see that first you see the nitric oxide. Nitric oxide means NO, right? And nitrogen dioxide NO2. So the when it is increasing, start increasing, right? You see that around like 6 p.m. Okay, so why? Huh? No, why you HU there? So 6 p.m. people start to go out. Okay, so 8 p.m. starts, 6 start there, right? So therefore, like here. So therefore, so is early morning traffics. So therefore, the nitric oxide started increasing. When the nitric oxide started increasing, then after that, depends upon that rate constant, right? They actually start reacting with the oxygen. Then you see that NO2 started increasing, right? NO2 started increasing. However, then after that NO2 plus H2 O, then O plus O2 O3. So, but the NO2, what you need? That H2 part. So more and more intense means more and more photons are there. So therefore, your ozone started increasing. Right? Ozone started increasing. Right? And you see that around like it's when there is like this noon time, right? So the sun is on top there, and it is mostly there, right? Los Angeles is sunny, right? That west side. So yeah. Right? And after that, then it started decreasing, right? It started decreasing ozone, and you see that nitrogen dioxide also start decreasing, and this you see that there is a NO is like is very less. So what is the thing that NO is like a very less? Why? Because the ozone is already there. You see the traffics are there, right? Now, for example, after this traffics are there, there is this emissions are there. However, when ozone is present, that is very strong reaction. The ozone, last ozone plus this O3 plus NO, NO2 plus O2. So still, if there is a emission is still present, however, you see that this nitric oxide level is really less. Ozones are eating it, but NO2 levels are still there. Okay. Fine. So that is the measurement data. What happens that when you calculate it, right? You can implement this type of all the things that they implement, and this photolysis is simply photolysis cycle you take, and the theoretical value. What it shows that the measurements are theoretical value. Whatever shows that it is actually underestimated, right? Underestimated means that from this theoretical value which is coming, it is lesser than this. So tan means, which means that this is not enough. What the photolysis cycle of this NO2, it is not enough, or it is there, but the sources of the NO2, it may not be only that thermal NOx, the fuel. there must be something else is also there, right? So that is the thing actually. The hydrocarbon. There is a hydrocarbon emissions also there from the fuels, from the other sources are there. Hydrocarbons, what happens that they also creates this NO2, N, right? And therefore that is these other sources that we need to check, which we can check on the next class. Okay, so this is the, you see that there will be like a big cycles and big reactions are there that we can take in a brief. Okay, in next class we can. Right, so this tomorrow we have a class. The Friday we don't have any class, right? Friday these project presentations are there, right?
Yes.
Okay, so next Monday we will take a quiz. Okay. Right, whatever up to tomorrow, whatever the syllabus we discuss, we will be having like enough time, right? I was planning for this Friday, then I realized that it is not there, right? And after that, next week is that we will have a full class, then semester, right? I will do it. Today only I will take it, okay? Today, so what I will do in that 7 to 7 that teams. That is okay, right? For
Yes, sir.
right? The teams that file section is there, I will put it there. Okay? So Moodle, then I am not giving in the Moodle. I think that is okay, right? Are you tagging?
Revision.
Abhirashi, Diwan, Deepak, Kirti, Archie, who is Archie? Saloni, Naina, Bharti, Prabhakar is there, Rachit, Anushka, Dipanjan, Jaya, Vinayak, Vikash, Ditu, Seduraman, Mukta, Sailesh, Shubhajit,
कल तक जो पढ़ा है
Harshit,
स्टार्ट किया है वहाँ से
प्रशांत,
कल तक जो पढ़ाई है कोई कोई नहीं हुआ
Abhayveer,
एक्सपीरियंस
Ankit,
फाइनल
Anushka,
क्लास में फाइनल क्लास
Ayush, Bano, Banwari, Ranjan, Richik, Aditya,
तो ये था कि
Aniket, Harshit, Raghunath, Vishal, Deepika, Divyanshu,